Hello! Today we'd like to show you how to use the Atmel Studio 6 and the Atmel software framework to create a simple application. Our application is going to toggle an LED at 2 Hz. So we create a new project for our board, which is the XMEGA-A3BU Xplained. Now what we'd like to do is use the timer driver of the XMEGA to do this. So what we do is we select a project in the menu bar and we select the ASF Wizard. This is going to show us a list of modules that are available for the XMEGA. Now on the right are already included modules, and on the left we can find our timer module a bit down the list, and we add it to our selection. Now, what we would like now is some sort of documentation. So what we do is we click ASF Explorer to the right. And here we get a list of available of the drivers that are available in our project. We can see the timer counter at the bottom. And if we open that, we see we have access to an API documentation and a quick start guide. We open the quick start guide. Now, as we can see, the first use case in the quick start guide fits our example. So what we're going to do is we're going to open it, and we can see that we have been supplied some code that will set up one of the timers to overflow at when it counts to 1000, and it is sourced by the system clock. So we'll just copy this code into our project. Now it looks a bit ugly, so we're just going to fix it a bit. And at the end of the program, we have to have a while loop so that the application will continue running. Now what this code does is set up a callback, which will be called each time the timer overflows. So in this callback, we would like to toggle the LED 0 on our board. We do that using a GPIO function, which we can find in the GPIO API documentation. You see, for this we can use GPIO toggle pin. We write it into our application, and we would like to toggle LED 0. So we write LED 0, and we can see LED 0 underscore GPIO comes up. Now the problem we have is that the timer period register is only 16 bits, which means we can only count to 65,000. That means that we would have to change the prescaler on our timer, which is now set to 1. So we would have to count to 2 MHz divided by 2, which is 1 million, which is too big. So to find out which prescaler we need, we throw up the calculator, write in 2 MHz, and divide it by the number of that we can count to, and then divide that by 2 Hz. We see that we would need a prescaler of 15.26. Now, if we go back to our source, we can see where the clock source is written. We can go using the Atmel Studio 6 go to definition hotkey, which is LG. We can see which prescalers we have available. We can see that 64 is the one we need for our project, which is the one that is closest to above 15. And now a simple calculation just to see which number we would have to count to. We divide 2 MHz by 64, and we divide it by 2 Hz, which we need. So we have to count to 15,625. After having selected our debugger, which is the JTAG-ICE3, we can compile and see if it runs. As we can see, the LED is now toggling at 2 Hz.